Hello everyone, welcome to this session. Today we will discuss about the electrical resistivity test, which is a geophysical techniques to know how the electric current, how the material are going to resist the flow of current. So this kind of techniques is uh, used for detection of various kind of geological information, water table detection, etc. So today we will see the overview of this electrical resistivity test. So let us begin with. So as we know, once we have some material, if it is conductive or non-conductive, so in case of conductive material, once you flow the current inside it, so different material had different ability to measure to make the path of flow of current. So, electrical resistivity measures the ability of a material to resist the flow of current. So, how much uh, current is going to be resist within this kind of material is known by the electrical resistivity. So, there are various methods which is used to measure the electrical resistivity. Four probe methods, Venner array method, and induced polarization method. We will discuss these methods one by one. So in four probe method, this is also called the Kelvin probe method. So it works on the principle that a unknown current is passed through the outer electrode while voltage is measured between the inner electrode. So the advantage of this method is highly accurate for measuring the resistivity of the thin film, semiconductor wafers, and the bulk material. So there are some limitations. It may not suitable for the material with very low or very high resistivity. Additionally, the accuracy of measurement depends on the probe spacing and the contact quality. Next method is the Venner array method. So in this method, we inject current into the ground by set of electrode and measure the resulting voltage difference at the another electrode. So this outer electrode will be insert a current and the voltage difference is measured as this current M and N. So according to the Ohm's law, V is equal to IR, where V is the voltage, I is the current, and R is the resistance. The resistivity of the subsurface material between the electrode M and N can be calculated using this formula. Rho is equal to 2 pi A into R M N. R is the resistance measured between the electrode M and N. Now, this Venner array method is having some advantage. This Venner array method of resistivity does not require the excavation or drilling. It is versatile. It can be used for ground exploration, environmental site assessment, and geotechnical investigation. Relatively simple and straightforward to set up. There are few limitations. The depth to which the resistivity can be measured effectively depends upon the electrode spacing. It may not provide the accurate results in the presence of the lateral changes in the subsurface resistivity. It is accurate measurement of the voltage and current for essential for accurate results. Sometimes it may not be suitable for the highly resistive or conductive material. Now there is a next method which is the induced polarization method. So it works on the principle that once the current is flowed towards the outer electrode and the current is going to flow for a certain time, and then the flow of current is stopped. Then the material which is inside the earth, it is having tendency to absorb some positive ion and negative ion on the surface of the body, and this will induce some kind of resistance or some kind of voltage difference which is measured in the absence of current. So this will the case of the induced polarization, means it is this polarization is this kind of positive and negative charges are gathered on the surface of this chargeable mass in the absence of or when the power is cut, power supply is cut, or electric current is going to be stopped. After that, there are some kind of polarization, some kind of ions are going to be gathered on the surface of chargeable body. So this will create the induced polarization. Let us understand in the descriptive manner. So when an electric current is applied, some material is stored and release the electric charge that is called the induced polarization. Geological material like sulfide mineral, clay, porous rock exhibit the induced polarization effect. Induced polarization measurement focus on the charges in the electrical response over the time after current is switched off. So how it is analyzed? The voltage difference, the voltage measurement over the time are analyzed to extract the chargeability information of the surface material. IP, the induced polarization data is typically presented in terms of the apparent chargeability, which is a measurement of how well a material can store and release the electric charge. So how we will interpret the outcome or the analysis? So the induced polarization data along with the traditional resistivity data are interpreted to gain the insights into the subsurface geology. Induced polarization data can help identifying the presence of mineral deposit, groundwater contamination, plumes, and geological structure. So there are few advantages of this induced polarization. So this induced polarization is particularly effective in detecting the material with chargeability, such as ore body, clay-rich formation, and some type of mineral. It provides additional information beyond traditional resistivity, making it valuable for mineral exploration and the environmental study. Induced polarization can distinguish between the different type of chargeable material in the subsurface. There are few limitations which are induced. The polarization data analysis can be more complex than the traditional resistivity method due to the time-dependent nature of the measurement. Conducting induced survey often requires specialized equipment and expertise. The depth of investigation with induced polarization may be limited and deeper target may be less accessible. There are few factors which will affect the resistivity. So these factors are temperature, moisture content, and sample size and shape. So the temperature, if we will see the temperature, so resistivity of the most of the material, especially metals and conductive material, tend to increase with the rise in the temperature. In terms of for the case of moisture content, the electrical resistivity of most of the material decreases as the moisture content increases because moistures act as a electrolyte, providing a conducting path for the flow of ions. Third one is the sample size and shape. The resistivity of material tends to be lower when measured on the large samples. So irregular shape or non-uniform samples can lead to their non-uniform current density, resulting in the variation in the resistivity measurement. Now, next is the what are the applications where this results of the or this electrical resistivity test can be used. So geotechnical engineering. So in geotechnical engineering, in identifying the subsurface conditions for the construction for the various construction projects, it can be used. And oil and gas exploration. So to assist in locating the hydrocarbon reservoir beneath the Earth's surface. So this oil and gas industry, they use the electrical resistivity test. So there are few case studies. There are few studies on the environmental aspects where detection of the underground water, which is having the some kind of contamination of minerals and other things, we will use the electrical resistivity test. Now, so in terms of how the results of electrical resistivity will work. So first in the depth, first is the baseline comparison. So that means there are some challenges which will faced due to the spacing of the electrodes which is used in the electrical resistivity test. So this electrode, so if you will increase the spacing of electrode or decrease the spacing of electrode, so you will see the effect in your results. And this is the very major concern while using the electrical resistivity test for any purpose. So once you make sure the calibration of their spacing and the how much variation are going to become when we are varying the spacing of the electrode. So there is a few challenges in the environments with the subtle variation. Achieving the meaningful results may require specialized equipment and techniques with high resolution. So what are the challenges which will come? So for deep subsurface investigation, there are other methods like seismic survey or borehole technique, which will give the more accurate about your subsurface condition. And tomography techniques I have already discussed. It will give your pictures of your horizontal distance as the variation of electrical resistivity along the depth as well as the horizontal distance. Now, the challenges which will be there in the electrical resistivity test, that is the complex geology. Electrical resistivity test assume homogeneity in the subsurface material, which may not be case in the geological complex environment with varying lithology and structure. Heterogeneous materials can lead to the ambiguous or challenging data interpretation. So, careful consideration of geological context is sometimes required. Noise and interpretation. So, environmental factors such as temperature variation, electromagnetic interference can be considered while performing the electrical resistivity test. So, the conclusion. So, what are the major conclusions? So, this method is versatile, non-destructive, accurate, and technological advancement. But if we will handle the procedures of gathering the data and analysis carefully, then this will work. So how it is versatile? So electrical resistivity tests are versatile and can be applied to a wider range of material and subsurface investigation, including the geophysics, civil engineering, especially in geotechnical engineering, environmental study, and the material science. Non-destructive. So these are the non-destructive methods that do not require to collect the sample by drilling or extraction. So and so that it will be kind of in situ measurement. If accuracy when performing the correctly, electrical resistivity test can provide the accurate and the reliable results, aiding in the characterization of materials and subsurface conditions. So it should have some technological advancement. So by the over the time, there are some kind of advancement in the instrumentation and data processing have been improved. So before going this kind of survey, you should make sure that the instrument which are you using, the person who are handling the data analysis and interpretations, and the knowledge and the experience behind this kind of techniques should be judged before you are going to carry out this test on your some kind of serious project. Uh, there are some future development like that should be there for any techniques. So similar to this, these techniques require advanced imagining techniques, automation in data analysis, and one should consider how the increase in the depth resolution can be improved, how the environmental effect that can be mitigated on the ERT results, and there is some kind of by the times the company who are making this kind of techniques they are innovating by the time, so we should make focus or we should be updated the recent updates about the technology. If you want to learn about the seismic method, so there are one session on the uh, MSW techniques on my YouTube channel where you can go and watch. Thank you so much.